Hi, so basically now we're going to look at another point called the crossover point. Okay, so what's a crossover point? We're comparing two different projects. The crossover point in the NPV profile is when the discount rate in both NPVs are equal. Okay, so it just tells you what discount rate you'll be indifferent to both the projects. So because both projects will have the same NPV. Okay. However, if your discount rate is higher or lower this value, then you have a clear understanding for which is your preferred project to invest in. Okay, so basically, how do we find a crossover point? What we actually do is we actually calculate the IRR of the difference of the two projects' cash flows. Okay, so that's pretty much it. So, how do we do it? Well, what happens is that we can use something like the solver to do so. Okay, so that makes it quite straightforward. So we can see over here, all right, we can use the cross point solver, but really the crossover point, as we've seen over here, is just taking the cash flow difference, right, and actually setting up what the IR is going to be. Okay, so let's just do it quickly. CF difference is going to be that minus that, okay, and copy that throughout, right? And we go equals to IRR of this whole bunch of stuff here. And it's 14%. Okay, so that's pretty simple, right? So that's the crossover point, okay? Alternatively, we can also use the solver too, right? Easy, we just click here, we click solver, all right? And we tell it that we want B27, which is the NPV of project A, to equal to C27, which is the NPV of project B, by changing cell B18, which is the WACC. Right? And the objective, okay, is to get B27 NPV to a value of 0. That's pretty much it. So let's say solve. Okay, so you can see it's selected 14 as well, right? So that's basically two ways of doing it, the cash flow differences in IRR, or just using solver, click on that, set the two NPVs to 0, and it just generates that. So that's happy days. So what happens is that we've said that, NPV is usually the better technique over the internal rate of return, right? But, NPV is not perfect. It has other issues. So some issues are the fact that, NPV doesn't consider risk or variance in cash flows, right? So we know that risk is as important as return, right? It's not just about how much money you get, but you're going to compare how much it varies too. Okay, obviously we would like to prefer if cash flows are constant over time, but let's say if they're constant at 10,000 for the next 10 years, that's great. But we would like it if it's 3,000 in the first year, 15,000 in the second year, then 8,000 in the third year, and so forth. So we want it to be as constant or as steady as possible. Okay, NPV doesn't really work when it's capital rationing constraints. Okay, so what happens is that sometimes you get the wrong project ranking if the highest NPV project is not necessarily the best anymore. There'll be another combination of projects if leftover funds are available. So NPV doesn't really allow a fair comparison when projects have different lengths, right? So one project might be 5 years, one project might be 3 years. So NPV isn't the best way to actually compare them both, right? So often we should use something like the equivalent annual annuity or replacement chain or lowest common multiple instead. So it's not perfect. So with IRR, it has its issues as we've seen before. So what happens is that, sometimes we can have multiple internal rates of return. Okay, so this is usually caused by the reinvestment rate assumption. So what happens is that we'll try to look at how to correct for the multiple IRR problem. We'll look at a modification of the IRR next week. So IRR function in Excel has guess options. So what is that? So if a project contains multiple IRRs, we can use the guess function to find the specific values. Okay, So we do this because otherwise Excel will just extract the same value again and again. So projects often have multiple IRRs when the cash flows are not conventional. That means you have, positive negative cash flows which aren't grouped together. They're kind of like different at every stage. So that's what we're going to look at, for example 4. Okay. Oops. All right, there we go. Okay. So let's take a following project as an example, right? So how many IRs does this project have? So the issue over here, okay, is that this project has negative cash flow, positive, and then negative at the very end, right? So what happens is that we're actually going to graph this chart. So what we're quickly going to do, we're going to have to create a chart with all the NPVs at different discount rates, just like we did before. Okay, so we have 0, 10, 20. Wait, let's change all these into percentages. So 0, 10, 20, and let's bring it down to a whole bunch of values. Okay, so for all these discount rates, right? So we're going to have the NPVs, and we're going to have equals to NPV of the rate, which is what we have here, and these values all the way up here, and we have that, and we minus of net 400. Okay, so this is going to be cash, or just that. This is wrong. Let's see what we've done here. NPV of A11 minus B2. That's actually right. So what happens is that what I do over here, change that to plus, okay? And what happens is going to make sure that it's all the correct fixed amounts over here. We make sure that A11, that we fix the column. We make sure that is fixed, okay? And we bring them all the way down, okay? So this gives us the NPV profile. So what we're going to do now, we're going to actually create a chart from that. Okay, so let's insert. We have a chart, and it's going to be that. And I really, really wish it would realize, okay, that I wish it would realize that this is actually the x-axis. I'm not sure why it keeps assuming that it's a y-axis, right? And I take away the discount rate here, and there we go. Okay. What I don't understand is how come it suddenly seems that Excel has become really quite silly in terms of like why change it to percentage into like percentages, right? It doesn't know that's even like a dollar amount. That is actually very frustrating. Okay. Okay, let's try that. Okay, that is better, right? Okay, so what happens is that and what happens, we have NPV on the y-axis and we have the IRR on the x-axis. Okay, so basically what happens is the NPV profile, right? So what we actually see over here, we have two IRRs as a result of the different cash flows we have over here. Okay, because we can see there are 2 points in which the profile actually touches zero, right? So basically what happens by charting out the IRR, okay, we can actually see that, like, we can find the two different internal rates of return, actually guess what the right one's going to be, okay? So what happens over here, okay, is that we can, so what happens is that we can actually use the IRR, which equals the ERR B2 to B8, right? And that gives us 3.94, which is the first IRR that we found, okay? But what happens is that we can go equals IRR, and it becomes B2 to B8, and we have 0.5. So this is a guess, okay, that there's going to be another IRR which is close to 50%. All right, we don't always need a guess. So basically, the first time we just pick the first one it found. But what happens when we say 0.5? It actually goes up to the value which is around 0.5, which was 45.98. Okay, so what happens is that we can see this project is multiple IRRs, two of them, because we look at the NPV profile, there are 2 points at which it crosses the x-axis. So we know that this project is only profitable if the investors require a rate of return that's between 3.94 and 45.98. So this is actually where we have two different IRRs. What we actually want to do is graph it, and we can see the two different ones. We can also use the IRR formulas, where we actually use the guess function, okay, in Excel. Okay, so that's actually what we need to do. So for those of you which are still confused by the guess function, let me bring a definition over here. Guess optional, a number that you guess is close to the result of IRR. So Microsoft Excel uses iterative technique for calculating IRR. Starting with the guess, IRR cycles through the calculation until the result is accurate within 0.001%. So what happened over here was that by plotting out the NPV, we saw that a good guess would be of 50%. So basically we gave that information to Excel 0.5 and it guessed that it will be 45.98 by iterating through the values.